It says first balance the equation. That is the step one for everything because we need the recipe. We need the correct recipe. So to get the correct recipe, we're going to balance. What we're going to do is I'm going to show you exactly how to use stoichiometry and answer these questions. Right? Then you are going to follow those instructions on the back. So pay attention here really well, understand, ask questions while I'm doing it if you don't know what I'm doing and why, because this, the back is your future. Make sense? We good to go? Does everyone have their calculator out and access to a periodic table, please? This looks a little wonky. Okay, that's better, right? Less wonky. Where's my calculator? Got it. Woo-hoo. Okay, so step one, we want to balance. We're going to just try the logic way first. So, okay. One aluminum here, one aluminum here. We're good to go. One hydrogen here and two here. I need to fix this side by putting a 2. That's the molar coefficient. So now I have 2 hydrogen and 2 hydrogen. Oh no. I have 2 chlorine here and 3 here. When you have 2 and 3, what do? Make 6. 2 and 3, we make 6. So if I multiply this by 2 and this by 3, wait, that doesn't work. Because then I need 3 hydrogens, right? So
Maybe 6.
I have to multiply this by 6.
Yeah.
Because this is 6 and that's 6. Yeah. So 6 HCl. I need 3 here. What has it done to my aluminum? 2 here. Everyone there? Are you sure? Is it bad that I had to cross something out? No. Make sure you completely cross it out so you don't go up and do anything. A says, what is the molar ratio between aluminum metal and hydrochloric acid? So when you answer these, notice you have a whole page. You have a whole page. And down at the bottom, see how it says pre-AP? This is the layout for AP exams. So not in chemistry, in all AP exams. So if you're planning on taking an AP test and solving any problem for an AP test, the AP test will list all of the questions that are linked, and you get a book or blank paper, even if it's digital, and then you take pictures of the blank paper. And there, I figured I'd start showing you the format. Who in here plans on taking an AP test one day? An AP test that would have a problem? Yeah, okay. So just showing you they'll give you just like this, a whole list of questions. What you want to do is you want to follow their guidance, show what your answer is to A, and then you're going to, when needed, use the verbiage in the question. So A is asking, what's the molar ratio between aluminum metal and hydrochloric acid? So up here, this is aluminum metal, and HCl is the hydrochloric acid. So the molar ratio between the two is 2 mole of aluminum over, because it's stoichiometry, right? It's not math. So you have to do a conversion factor over 6 mole HCl, right? That is the mole ratio. Make sense to you guys? Cool. We've answered A. Now let's answer B. What is the molar ratio between aluminum metal and hydrogen gas? Everyone think they can do that? 2 mole of aluminum metal. And what do I put on the bottom? I need to put 3 things on the bottom. Which one is hydrogen gas up here? H2. So what do I write down here? 3 mole, what? H2. Yes, sir.
For A, do we not simplify that down?
Nope. Stoichiometry. Stoichiometry. With me? Okay. C says how many moles of aluminum metal? So they're asking for moles of aluminum metal. That's what they want. That's so our answer is going to be blank moles of aluminum metal. And it says are needed to produce 3.33 moles of aluminum chloride. Looking up here, can you tell which formula is aluminum chloride? You sure can now, right? So this is what's in the kitchen, right? This is what's in the kitchen, and this is the recipe. Write what you're given. So that would be 3.33. I know you can't see 3.33 mole, not exactly not the words. These are the symbols. And that is of AlCl3. That's what you're given. This is where stoichiometry comes in. It's not optional. I'm going to multiply it by a mole ratio. Now, stoichiometry is all about canceling what's on the bottom. So what's definitely going on the bottom here is mole AlCl3. That's what's going on the bottom. What is it asking me to compare? Am I comparing this to that? Am I comparing the aluminum chloride to the hydrogen gas? Am I comparing the aluminum chloride to the acid? Or am I comparing the aluminum chloride to the aluminum? What is it asking? Aluminum chloride to the aluminum metal. So the conversion factor is for every 2 moles of aluminum chloride, you need 2 moles of aluminum metal. Not real difficult, right? Then it's equals. You don't come underneath, it's the line. You're going all the way across the line. So how many moles? Hopefully you guys knew that. Mole aluminum, right? And if you were really training for the AP exam, you would say needed. You would use the same verb, the same verbiage that's in the question. Then you would box the answer. Now, D. They're going to give you something and they're going to ask for something. In D, they're asking for moles of hydrochloric acid. So instead of asking for this, they're asking for moles of hydrochloric acid, and it's saying needed to react with the number of moles of aluminum metal in question 1C. Well, what was our moles of aluminum metal? This is our moles of aluminum metal, right? So we start with 3.33 mole of aluminum, and I'm going to multiply it by a mole ratio. What do I know about the mole ratio 100%? That mole of aluminum must go here. Do you see how you cancel on the diagonal? Anything over itself cancels out. Anything over itself cancels out. So this is going to cancel out. How do I know what to put on top? What are they asking for? Hydrochloric acid. So mole ratio between the two. There are 2 moles of aluminum for every 6 mole of hydrochloric acid. Notice this relationship, conversion factor, is identical to A. You flip it how you need it, right? You just flip it how you need it. We needed the aluminum on the bottom. Here, we follow how it's written. Aluminum and hydrochloric acid, aluminum on top, hydrochloric acid on the bottom. But we can flip that relationship. There's 7 days in 1 week. 1 week is 7 days. You can flip the relationship as you need it. So in your calculator, everyone in your calculator right now, I know you know it. I know you can do it in your head, but you will multiply going across. Watch my finger. You're going to multiply 3.33 times 6. Watch my finger. 3.33 times 6 equals nothing else there. Then you come back. When you come back, that's divided by 2. And then you hit equals again. So 3.33 times 6. Then you hit equals. And then as soon as you go to the next line, you hit divided by 2 equals. That's exactly what you could see in your calculator. This, then you have that, then you have answer divided by 2, then you have that. Does that make sense to everyone? Is that exactly what you see? Okay. You do know it's going to get more complicated. Okay. So 9.99, what are my units and subject? Mole of HCl. Now notice I didn't write of, so don't write of. This is here. And what word should I add if I was just an overachiever? Needed. And boxing. E. It's asking how many molecules of hydrochloric acid are needed to react with the number of moles of aluminum metal in question 1C. How many molecules of hydrochloric acid are needed? So we're starting with the same thing. 3.33 moles of aluminum. We don't want to talk about aluminum anymore. We want to talk about hydrochloric acid. So we're multiplying by the mole ratio, 2 moles of aluminum for every 6 moles of hydrochloric acid, right? And if we were to stop now, we would get moles, but it asked us for molecules. So we're not stopping. One mole of anything is 6.02 times 10 to the 23rd, right? So I know I'm going to multiply it by another conversion factor, and I know mole of HCl must go down here, and I'm trying to get to molecules. So it's up here. 1 mole of anything is 6.022 times 10 to the 23rd. Equal, and I'm putting my answer here. It's in a line. I'm not going underneath. It's in a line. So in your calculator, follow my finger. 3.33 times 6 times 6.022 second function EE. You have to do second function EE 23. Second function EE 23, hit equals. So 3.33 times 6 times 6.022, second function E 23. And hit equals. So check your calculator out. It should have this 3.33 times 6 times 6.022 E23. If it doesn't, if you're using the same old way for your scientific notation, you will not always get the right answer because of what's coming up. Okay. And then you hit equals and you see this, right? But equals, now we go to the bottom. So what do we hit? Divided by. So it's taking this and I'm dividing by what? 2 and hitting equals. And now I get this. Now, how many sig figs in my answer? Comes from what I'm getting, right? It comes from the beginning, has nothing to do with conversion factors. Has to do with this. So 3. So I will write what? 6.02 times 10. So what? 24. Now, what are my units? Molecules. What's my subject? HCl. And is there a verb? Needed. That's only if you're an overachiever. No. HCl is hydrochloric acid. Right? Mole of HCl's cancel out. We're talking molecules of HCl. 1 mole of 1 dozen cars is 12 cars. 1 mole of HCl is 6.022 times 10 to the 23rd molecules of HCl.
So I want to write HCl next to molecules.
You're more than welcome to. Yeah. What?
I just want to ask,
Yes, HCl. Now, let me tell you what I do is you cannot abbreviate molecules with mole, mole E, or anything like that. But what you will see is it's abbreviated apostrophe CUL. It's nice and short. So molecule, right? This apostrophe stands for the molecule. Now, you can do that through your stoich, but you can't do it for a final answer. Right? You can do that through your stoich, but you can't do it for a final answer. Now, Raimundo, he only uses CUL without the apostrophe. I was taught the apostrophe. He was just taught CUL. I'm not going to mark off if you just use CUL. But you'll see me use apostrophe. Make sense? Now, this is not making up our own. You don't make up your own abbreviation. Okay. F. How many grams of hydrochloric acid are needed to react with the number of moles of aluminum metal in question 1C? Does you guys know exactly what we're going to do next? Anyone know exactly what we're going to do next? Yeah?
What do you think after the last one except for 6.022 times 10 to the 23rd on top, you're going to find the total molar mass in grams of 1 hydrochloride.
Yep. We're going to change, we're going to do the same thing, but we're going to change this conversion factor to the molar mass of hydrochloric acid. So F, do you have to write it all again? Yes. 3.33 mole aluminum times the mole ratio, because I want to stop talking about moles of aluminum and I want to start talking about mole of HCl. And then 1 mole of HCl is 35.45 plus 1.01, and I get 36.46 grams of HCl. This is the molar mass. Remember, your molar mass is grams per mole. Grams per mole. I could also flip it and make it moles per gram, right? If I needed it. If I was given grams, I can convert it to moles. But here, I'm starting with moles and I'm converting to grams. My moles of aluminum are gone. My moles of HCl are gone. I'm left with grams of HCl. And that's what it's asking for, grams of HCl. So in your calculator, you know what you're doing? Everything stays in your calculator. You do not hit equals and write that down. You will lose, look at me, look at me, look at me. You will lose points if you do that. If you multiply across and give me the product here, and multiply on the bottom and give me the product here, you will lose points. Does everyone understand that? You're not in math, you're in chemistry. If you must write that down, write it down on your own paper, write it down on the freaking desk. Do not write it down on something you're turning in. Don't lose the point. I didn't realize how much you guys like writing on the desk until I wrote on the desk yesterday. It was awesome. It's so smooth and it makes your pencil kind of shiny so you can do all kinds of stuff. I wrote all over Mr. Raimondo's desk. It was awesome. I wanted to do an entire thing. Right? You can even write on the desk with eraser. It's so smooth. Is that what it is? Is it because it's so smooth? Go at it. Go at it. Okay. So 3.33 times 6 times 36.46 hit equals, then divided by 2 hit equals. What do we get?
4.2.
How many sig figs in our answer? 3. So 3, 6, 4. What are my units?
Grams.
What's my subject? HCl. And if I want to be an overachiever, I would say needed. And I box the answer. So that's how you would set up and answer AP questions. So format, all of your work for A, you will continue. If you needed more room for A, then you don't start B right away. Maybe A takes you this whole amount, but as soon as you start B, you indicate where you start B. As soon as you start the next one, you indicate where you start the next one. Make sense? Okay, everyone, please turn it over. And I'd like you to do this one in its entirety, exactly how I showed you to do the other one. When you're not sure what to do, flip back and see what I was doing. And you will be turning this in today. You will be turning this in today. I just want to check that you're there. So I'm going to give you 15 minutes, you think, for this? 20 minutes. That's it. I'm setting a timer and then it's pencils down. By yourself. You're following the exact method on the other side. side note for this unit is called carbon chemistry. Carbon chemistry. So we're going to spend all year looking at 92 elements and all they can do and all their trends. And if you go to university in the science, you'll spend all year studying one square of the periodic table, which is kind of cool. You're going to study the carbon square. And we know right now that carbon has 4 valence electrons in the outer orbital. Well, what that means is carbon can form 4 bonds, right? Can form 4 bonds, and that's called being tetra, because tetra means 4. Remember the game Tetris and all the blocks were 4? Tetravalent, right? Because carbon is tetravalent, it lends itself to be able to make many, many simple organic compounds, okay? Right under it is silicon, which is also tetravalent. And if you're a sci-fi fan, like I am, it is scientifically valid that another complex life form would be silicon based. Because of the versatility you get per carbon, the only other element that does that would be silicon. And it would be able to handle greater pressures, which would be different planetary situations. So anyway, carbon chemistry, otherwise known as organic chemistry, is all based on the fact that carbon is tetravalent. Because it's tetravalent, it can make simple organic chemicals. And we know one, or at least we should have memorized one, CH4. That is when you have a carbon and it's bound to 4 hydrogens. That is CH4. That's a simple organic chemical because this is tetravalent. Now, it can also form chains. So if we link 2 carbons together, it's like a double methane here. Can you look at this and tell me its formula? C2H6. H6. And C2H6. Now we know this is called methane because I told you to learn that. Right? Methane, CH4 is methane. And well, with 2 carbons, we're going to use a different prefix. So you might want to over here. Yep, let me do here. Meth is 1. What is 2? F. 3? Pro or PROP?
Yeah.
PROP, prop. Meth F prop but. Meth F prop but is 4, and then it makes more sense. Have you heard of meth F prop but? Not so much, but you've heard of pentagon, pent for 5, and hex for 6, hept for 7. What's 8? Hot for 8, and non for 9. What that's talking about is how many carbons. So we can link, let's do C5H12. C5H12. So that's going to be a carbon to a carbon to a carbon to a carbon to a carbon. Those are my 5 carbons. And then the only other thing there is hydrogens, and 5, 10, 11, 12. So I'll put these here. Now, do we know what this is called?
Okay.
Pentane. Yes, this is pentane. Oh, and I forgot to name the one above it. What is this called? Ethane. Ethane. Pentane. Now, there is another way to write this formula. And that is, it's in between writing the full structure or just the formula. It's kind of like a structural formula. So we would write our first part of the formula, CH3. CH3. Then we'd write the next part of the formula. What's the next part? CH2. Then we'd write the next part and the next part. So CH2, CH2, and then we ended up with CH3. Left to right, you see something this long. It's this, but it's showing you how to write it out. Showing you how to write it out. Well, why would we need this? Well, it's not always hydrogens. It's not always hydrogens. The worksheet that you have to learn the naming is just hydrocarbons. Just hydrocarbons on that worksheet. And so what these guys have in common and what ane represents is that all of the carbon-carbon bonds, all of these carbon-carbon bonds are single bonds. It's a single covalent. Obviously, it'd be non-polar because they're of equal electronegativity value, carbon to carbon, carbon to carbon, carbon to carbon, non-polar bonds. But if I were, so all of the carbon to carbon bonds are single, you're going to end it in ane. But carbon to carbon can have double bonds. If it's a double bond, you end in ene. And if it's a carbon to carbon triple bond, you end in ine. Ine. Now, a single bond is longer and weaker. A double bond is shorter than a single bond and stronger. And a triple bond is even shorter than a double bond and super strong. It's like 3 hands holding you versus 2 hands holding you versus 1 hand holding, right? So strength and bond length. So the bond length is shorter, the bond length is longer. It actually changes size of molecules. It actually will change the different size. But let's draw, let's draw this guy. If I have a double bond, and let's just do the 2 carbons. So I know it's going to start with F, right? F. Now, carbon can only have 4 lines around it. Right? Because 4 lines represents the full octet. So this is going to be called ethene. And what is the chemical formula? C2H4. Notice that the number of hydrogens is twice the number of carbons. So that's where the formulas come into it. Number of carbons. So here it's 2x, where x is the number of carbon. So your hydrogens equal 2 times your number of carbons. Number of carbons. For ane, H equals 2x, x is number of carbons, minus 2, and for ine, H equals 2x plus 2.
It's the other way around.
It is the other way around. this is plus, and this is minus. Thank you. And why is that so? Let's draw a triple bond. How many hydrogens can I add? Well, each carbon can only handle one more bond. So this is C2H2. What's it named? Ethine. This bond is stronger, right? Still nonpolar, but super strong. It's shorter also. Yeah, shorter also. Now, so you see the name changes for the bonds. If you have a hydrocarbon chain that links up the prefix, when I say links up, if it forms a ring, if chain forms a ring, you're going to use the prefix cyclo. So you can have cyclo. Tell me what this is. Cyclohexane. So you wouldn't draw a chain, right? You wouldn't do C, 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 C. That's a chain. What would I do? I'd do C, 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 1, 2, 3, 4, 5, 6. Cyclohexane. It's a circle, right? So it's not in the chain, it's in a circle. So prefix, now this is only going to happen when they're bigger, right? It's only going to happen when they're bigger. Also, chains can, so they can form rings. This is a ring. They can form ring. They can also branch, right? If I go C, 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 and from here I go C, and from here I go C. So 1, 2, 3, 4, 5, 6, right? So this is a branch. It's still the 6, right? But when it's branched, the prefix is iso. Iso. Prefix is iso or branched. B-R-A-N-C-H-E-D for branched. So this would be called isohexane. Make sense? So iso, if it's branched, cyclo, if it's a ring, and the last bit of notes is when we don't have just hydrogens, we can add something else other than hydrogen. And what we add are called functional groups. Functional groups. And basically, instead of adding a hydrogen, one of the functional groups, you could add an OH, right? Adding an OH, let's say R is the hydrocarbon. R is the hydrocarbon. That's just an abbreviation for whatever the chain is. It would be bound to an oxygen, which is then bound to a hydrogen. And to make oxygen happy, it would have the 2 unbound pairs. This OH, you probably already know what it's called. It has, here you're going to have an ending. So this is, what is it called when it's an ending? Suffix, right? So we had the others were prefixes. These are suffixes. And ANOL. You'd have a suffix. So you could have propanol. that means propane, but one of the hydrogens is replaced with an OH. Have you heard of alcohols, guys? Alcohols will have an OH in their formula, right? So anols is a type of alcohol. Propanol, methanol, butanol, right? They're all OH. So a functional group replacing one of, so this guy, let's do the CH3. And then let's do CH2. And then let's do B8. And then let's do OH. So 1, 2, 3. How many? Meth, F, prop, right? Single. So is it ein, or ein? Ein. So propane, propanol, propanol, propanol. Okay. Making sense?
Yeah.
Propanol. So that's one functional group. Another one, again, R is the chain. R is just the chain. Another one is SH. Very similar to OH, but this would be, the suffix would be thiol, THIOL, thiols. Disulfide bridges in biology. Anyone remember disulfide bridges? Okay, never mind then. Another one is N, right? An H and something else. I'm going to put an X. So when you see N added to a hydrocarbon chain, this is an amine. Reminds you of amino acids, doesn't it? Amine, ammonia, all that stuff, all that's N-based. Then we have what's called a carbonyl. So we have an R group, right? Bound to a carbon. Now carbonyl is double bound to an oxygen and then a hydrogen. So this is called a carbonyl, NYL, carbonyl or carbonyl, and it is not represented in the name. So not in name per se at this point. Yeah.
Is that like a suffix or is that just?
No, it is not. So that's what I'm saying. It's not in name. It's called a carbonyl or a carbonyl or carbonyl group, but it's not part of the name. So it's not a suffix or a prefix. Now, why this is important is because it's polar. So if you see this, it's going to turn a very nonpolar molecule polar. Why do we care if it's polar? Will it dissolve in water? Right? This is different than this, right? It is different. The other one is called a carboxyl, BOXYL. And I remembered carboxyl because OXY to me stands for oxygen, and it looks just like a carbonyl, except for it has an extra oxygen. So we're double bonded to an O, and then we're bonded to an O, which is bonded to the H. So carboxyl is this guy. A carboxyl is this guy. Again, it's not part of the name at this level for you guys. But because of this, this guy is a weak acid because it can drop off this proton. And obviously it is, this guy is polar, but this is hydrogen bond polar. So really polar. H bond polar. Remember, you can be kind of polar and you can be really polar. H bond is really, really polar. And that's because oxygen is basically ripping the electrons from hydrogen. Remember, oxygen, electronegative, taking all the oxygens. And the last one on an R group is CH3. Now this is this is called methyl. And this is part of the name. This is within the name. So it's not a suffix, it's not a prefix, it literally goes in the middle of a name. I know, you're like, I know. For example, this branched guy, this would be this, right? So we're going to get to, we actually name the we actually number the carbons, and then on 3, have you seen chemical names with numbers in them? Like on your shampoo bottles, 1, 3, methyl. So this is like a 3-methyl, there's a hexane, 3-methyl hexane. Well, I post these notes on Schoology. Can you just take a picture of them?
Also, mine's recording is always on.
I'm recording now. I'll put that on. The thing is yes, it will, but they're not as neat as I'd like them. Are you sure?
Yeah, they look really.
Oh, because I screwed up there. I wrote over this. I crossed that. Okay.
If it's legible, that's really.
Okay. I'm sorry. I will scan them in and post them. Yeah.
Are the homework or just take?
Your homework is to do the hydrocarbon sheet.
That's it.
Yeah, because you turned in that. So your homework is to finish the hydrocarbon sheet.
Okay.
And if you lose it, it is posted. Wait a second, I'll see you Friday, right?
Yeah.
I was gonna say have a great weekend. You win.
I'll see you after school because I'm gonna come today to do my science and try and finish it hopefully. Yeah, but I got makeup remover and I also got Marcellin water. I was like,
So I was thinking, I thought of this, I was thinking we should probably make a solution from the mascara. Put the solution on the paint. Like in little beakers, using the Q-tips, kind of mix up a solution
yeah.
and then get the paper to hold it, and then run it through.
So
So,
that way we might get actually some
yeah,
data.
but did you see the note on the door? I have a meeting with the superintendent of Essex County today from 3 to 4.
Okay.
So you can come afterwards.
Okay.
Totally 100% you can come afterwards.
Okay. So I can come up for.
Thank you.
Well, I think I said 4:15, just in case,
Okay.
but I'm cool with that.
Yeah.
Yeah, so I put that on the door for
Yeah.
mainly you, but other.
I'll just, I need to talk to my parents, but I'll like, I think it should be good. So, yeah.
Yeah, if not, I'm here all week.
Yeah, it's just hard because like I have practice and like we're like just starting the season, so like weeks are heavy and blah blah blah. So it's
Yeah.
hard with my coach, but he's fine with it. He's chill. So I mean, it's education.
Education comes
So,
first, it sure
yeah.
does.
What's going on Friday?
That's Friday.
What's going on Friday?
You're turning that in?
Oh.
You're turning the hydrocarbon guy in? Hello, you're early. How do you get out of your other class fast?
It's different.
No.
Oh.
Okay, so AP. What am I doing? Okay. Yeah.
The lab where you burn the paper steam.
Yes.
That's why it smells like burnt. And it smells like, yeah, like, or like cotton candy. Yeah.
They're also melting, they're doing your ionics and covalents, and the covalents melt, so the sugar turns into that, they're doing that in the labs too.
It's not even.
I don't know. Merry Christmas. Thank you.
Okay, good.
I went to the cafeteria. Actually, I asked people at work.